everybody. It's nice to see you all back after lunch. We will crack on with this afternoon. We've still got a packed schedule, and I'm here to introduce Paul Adams, who will be talking about testing AI and smart supervisors. So over to you.
Thank you very much. Welcome. You're all tired and want to go to sleep now. That's such a nice dinner. Let's try and keep you awake and do some interesting discussions. Any of you use AI? Brilliant, some experts. Any of you test AI? Fantastic, some other experts as well. Any of you want to use AI? Some other experts. Brilliant. Any of you know of children using AI?
Yes.
Yeah. Children. Yeah, for their homework. Coming into professional field, people going in just to university courses, they're going in as experts in using AI. It's going to become the norm. It's the norm now in schools. At O level, never mind A level, it's the norm. And if somebody in the class has found out how to use a bit of AI, it'll go around that class like that whole school like wildfire. Way above what we're using. Yeah, we're not experts in using AI. We've grown up before AI times. These kids have grown up with AI and using it and knowing what to do with it and exploring and changing things and doing all sorts of wonderful things. Big problem, big gap in all of software testing really, is that as we get AI systems and they're doing more and more of the stuff that we used to do, and more of the stuff that we do in our software and our systems, but we're not really capturing testing it. So I think we had 2 hands go up for people actually testing AI. Out of a group of experts in software testing. Doesn't that make you a little bit scary? And your kids, your school kids are using AI. And just about every big software development company will be using AI somewhere in their systems. Every big organization will be using AI somewhere in the systems. And out of this group of esteemed experts, really experts in software testing, going back, and 2 people put their hands up to say they're testing it. That should show a massive gap. This is a bit that I want to talk about, really, and how to fill that gap. Like some practical tools. So, you've seen all this, you've probably covered most of this, the 7 principles of software testing. We can go back to this in support systems early, but we're in about the 4th wave of AI now, probably 5th wave really. But it's not something completely new now. We've had expert systems, decision support systems in the 80s and so on and later. And we've got a whole bunch of things about AI algorithms. And we talk about AI as if it's one thing. There's a whole bunch of different types of AI and probably all different types and needs for testing. So there's other things to think about. And also people talk about high level and low level in AI. So the low level, the nitty gritty algorithms and other things with that. And the high level, hey, let's think about top level generative AI, that we can have a robot that can manage its exploration around Mars or something and deal with all the things that environment throws at it. So we have, again, lots of different thinking about different types of AI that we need to consider. And what we talk about actually, the self-changing stuff, it isn't really just related to AI and business use. You've got a whole genre of computer science, which has very similar attributes. So you've got DNA computing, nano-level computing, which is a stream in computer science from the 1990s, early 1990s. They're following the same sort of issues, but their issues are a bit more explicit when you look at it. as an outside, as an expert tester from the outside, because they have many of the fundamental problems that we have as testers. We become experts at testing, and then we talk to the users. They're experts at being users, but they don't know what they want because the system's already changed, so they don't know what they're going to do with it. And they have the developers, different animal altogether. You tell them what they want and they'll make something for you. You give the same problem to 3 or 4 different testers and they'll come up with 3 or 4 different solutions. And then you get the design people. So you've got people with different languages. And it's even more so when you look at the level, because you've got mathematicians, physicists, chemists, and computer scientists. God knows what language is a common language between them. But they're all talking different languages. It's the same when you look at AI. Because you have lots of different levels of AI, don't they? Different varieties. And they're all looking at testing from a different perspective. They're all looking at requirements from a different perspective and potential use cases and potential mishaps and risks. Right. So we've got all the things that was discussed earlier. Things like the importance of the user. Actually talking to the user and looking at what their requirements are and seeing how those evolve, because that will change. Looking at the different stakeholders, the tester and the specialist in that, and the need to nail down requirements, where the AI is, well, it's not about nailing down requirements, it's about exploring new stuff, finding new patterns, finding things outside of what the people are looking for at the moment. Making things a lot easier and stuff. Missing out all the steps that probably would need to do along the way before we came up with those solutions. So let's go through some of these. So the 7 principles of software testing, you probably cover this over and over again. Yeah. Absence of errors fallacy. Because you don't find it, doesn't mean there's any there. All these elements here, where it's so ingrained in what we look at when we talk about testing, and trying to get that message across to the people holding the purse strings, the managers, and say, well, yes, we've tested. It doesn't mean it's 100%. It means we haven't found any errors, and we've got some level of quality embedded in this, all that sort of stuff. And you've got wonderful standards of how to do the testing. And again, when we look at AI, these are those principles sort of been stretched a little bit. I'll throw in some other principles of software testing, and you've probably got a few of your own to throw in as well. Usually done last year, we've all come across that. The testing gets pushed down. I won't go through all of these. I'll pick on that one though. The best people, well, often the best people aren't interested in testing. They want to develop something new. And they've got this fantastic design, which won't build on anything that anybody else has done, but they've come up with this fantastic new idea. And this is the creative spirit. And software development is probably one of the most creative industries out there. People are coming up with solutions to problems. We've got these sets of requirements, of problems, and you give it to developers, and they'll come up with this fantastic solution, and then they'll expect somebody else to test it for them. Big challenges there. And the users, they don't know really what they want to use this new system for. We design a system based on their requirements, and they use it for 6 months, and then their requirements change. And then if we knew that at the start, we would have developed a different system. It's that sort of thinking often. It's completely evolving. And you've probably got a few others, life and work experience in trying to test these systems that are completely changing and evolving. Again, AI has been changing, and the concepts of AI. First adaptive system I was involved in was in the 1980s, early in the 80s, where we was developing something in assembler, and we had self-changing code. Scary stuff. It was unstable after several iterations, right? And you have the same sort of principles now coming out with, using the latest high-level language, natural languages, all sorts of things, adaptive systems, where it's going to change what we have. It's going to build on what we've got before and change that. It will take some data, generate some new data, and use that data again in the next phase. Oh, wonderful stuff. But you've got lots of teams of experts in the early ones, and they had input into those systems. So you had your expert systems, and embedded in the testing of those expert systems were the experts. So the experts often didn't agree, but they were able to identify how the expert system came up with an answer. And they're trying to embed that in that type of thinking in transparent AI and explainable AI. But with adaptive systems, it becomes a bit of a challenge. So we got some idea of the mechanisms, the processes that the adaptive stuff takes place, but we don't know the detail of how it comes up with. So we're missing some of these things. And again, we often saw that the actual expert systems soon became justifiable systems. So a system to explain something can come up with an answer, and it's often used very differently. So this idea of changing requirements and changing needs and changing a mindset of what that system is there for. So the early banking systems for giving things like mortgage or whatever, the early expert systems in that, instead of being justifying why you come up with a reason, you come up with a solution and give it to the manager, but for him or her to come up with why you're going to get a mortgage or not, it just come up with the answer. You got this because of, without the human expert being in that loop. So we've seen, certainly in the case of the expert systems, that how people use them and why people use them changed over time. And we could reasonably expect that AI systems will probably, current AI system will probably go through the same set of processes, that it will change. Maybe some justifying of something in the future, it may be changing some practices in the future, but we can expect that it will be different to what we're developing them now. Every system that we've had produced of any different size, they've always evolved, and the justification for the system and the reasons for using those systems have evolved as well. Testing in AI. Well, there's a lot of testing goes on in AI. It's not completely new, this concept of testing for AI systems. But what gets tested is very different to what probably many experts in testing consider. So an AI expert, they'll develop this new algorithm, new system based on this new algorithm on a set of data, maybe generate a set of data. They'll be looking at proving that their new system, their new algorithm is better than the previous ones. That's finding a solution quicker, finding a different type of solution maybe. And somehow then they'll pass that as testing. There'll be a big tick. Yes, it's quicker. We only spent 3 milliseconds in coming with that solution, and it's captured a new element, whatever that will be. So all the things that we've been talking about this morning, really important things involving the user, making sure it's accessible to different user groups, making sure that we go through a process of nailing down what the requirements are so it meets the needs of the users. All those things sort of don't fit into those mindsets. So we're dealing with a different set of mindsets. Data, they use, again, a whole bunch of data for training the system, and then they'll test out the system on the other half of that data. Again, the mindset here is, yeah, this is a good scientific approach. It's got a lot of foundation for it. You've gone through a good testing. You're testing it out on half the data to develop the models and then really applying that in the next bit. And again, that's further testing. But you've got a proof of concept, and then you're testing that proof. And again, if you go back to the testing sort of principles, often when you're sitting down with clients and saying, well, we're going to test this, what you work through, well, what is the aims of this test? What are we trying to achieve? What is this system supposed to do, and what are we trying to achieve when we're testing it? And when you look at AI, you've probably got something new. You're probably looking at, well, we're going to try and explore new options, new solutions, which again goes down to you're nailing down those requirements. And you want to test whether your system matches those requirements. How do you actually nail down, you're trying to look for something new, something that we haven't found before, and something that is better and producing something better. And again, yeah, it becomes a bit of a challenge if you don't, it's new, we don't know what it is going to be yet. Lots of challenges. And then often like the AI stuff comes up with a good solution. Yeah. Simulated annealing, it comes up with a pretty good solution to a problem. It finds wonderful mathematical stuff. It finds a solution for this very complex problem. But it's not necessarily the best solution. It's not very necessarily the most resilient solution. It comes up with a good solution. And the idea of, well, what is good? And how do you actually work out, well, what would be a best solution? How would we actually articulate what would be a best solution? Big challenges there. And then again, I mentioned the high and the low levels. Yeah, low level stuff, autonomics. So if you're looking at, say, a low level example, big network systems running, connecting up the internet and so on there. So you've got the big routers connecting up with now that they're working in real time, massive amounts of data, and he's trying to work out the best routes. Right. If you've got a human in that loop, they'll slow things down. So they have automated adaptive systems, lots of AI, lots of feedback mechanisms in that, lots of self-management, lots of optimizing, lots of self-optimizing in the solution. At the high level, again, this is a lot of self stuff, more self-adapting, self-learning, self-healing. So if you think of a rover on Mars, so it's got to manage its whole environment. So this is the higher level thinking now. So again, trying to take on board more of the stuff that maybe humans will be able to do. The autonomic element, again, this is a self stuff really. Maybe we're looking at self-modifying, perhaps self-aware. Certainly at the low level, the units there are aware of each other, they're communicating. And again, the idea that the unit itself would be independent and autonomic requires some level of self-awareness and awareness of the environment. Lots of interesting philosophical sort of things out there. And again, the significant challenge, how do you actually test that? It's all like, was it one of the yeah, brilliant. You know, the known unknowns and the unknown unknowns. How do we actually deal with that? This is what the humans are pretty good at doing. In fact, most animals are pretty good at doing that. You know, and this is where some of the AI is sort of moving into that territory, perhaps. I'll put this word there, hope, in red there. Because when we look at testing AI and looking at the aims and scopes of AI systems, you see the terminology they use, and it's like, oh, we want an AI system to do this. So, excuse me. We want an AI system to find cancer cells in whatever. Yeah, and there's a lot of hope embedded in the requirements. And we're not always fulfilling that hope, and the AI system will probably not fulfill that hope because some of that hope is outside of what we can reasonably expect. And probably the AI requirements are quite fuzzy, and the testing requirements are going to be quite fuzzy. So if back down into Colin's discussion about nailing down the requirements, this is going to be a big challenge, but we've got to do it. We've got to find some way to capture that, maybe. And it will evolve. And we've already pointed to this, that you move to an explaining system to a justifying system. That these are the answers because, well, the AI system came up with it. Yeah, and that's probably some of the justification that what people need for something. So when we look at how to test self-adaptation, self-control, and what will be the success of that self stuff, perhaps we can look at kids. Kids are a good example. They're wonderful learning instruments. They got so much innovation, so much energy. You teach them stuff, and then we want to test whether they've understood that. We give them a test, and we ask them yeah, thanks, brilliant. I'm going to zoom through the rest of these. So that may be a pretty good way to do it. So you ask them the knowledge on how they would answer a problem in a particular case. So that may be a good approach, that self element. Same sort of stuff here. Let's move on to, well, lots of different types of AI. Perhaps we will want different types of testing for the different types of AI. Again, they're based on different sciences, different data sciences, certainly. You have the deep learning for self-adaptive systems, even down to artificial consciousness, self-consciousness elements. How do we actually test that out? The Turing test, yeah, but that's not really capturing all the end, and you can bluff that anyway. Let's move on to so the different approaches, heuristics. These were used in early expert systems, these approaches for testing the system. Scenario approaches, an ethical approach that's been suggested. So you have if you like, a line in the sand of what can be covered and what can't be covered by the AI, what can be used and can't be used. And again, taking an ethical stance of and understand the impact from the different stakeholders. And then the outputs. This will be probably more that testing, seeing whether the child has understood what you've explained. The real core of where I'm coming from is a metadata approach. This is one of the things we're doing on one of the funded projects, and it's trying to capture the attributes of a system and use that as a base to say whether this is appropriate for the next use. Because a lot of AI is a lot of reused elements. It's all based on reuse, really. Very rare do you get something created from scratch, completely from scratch. You'll use an existing base algorithm or set of algorithms, an existing base set of data, an existing base model of how it all fits together, or what it's all supposed to do. So you get a lot of reuse. So the affordances mapping is really capturing the attributes of each element of an AI, and then put those together in a metadata model. Yeah, we use a standard model for that, and extended. It's the LOM model in international standard already, and we extend it. So the idea is that you can create one AI system, you capture it, all the elements of it, you capture the different attributes, and then you're able to take the bits that are relevant to the new use and say which bits are relevant. We can use those. Which bits are out of date? Which data sets are out of date? Where do we need to get new data sets to address that? Bounds of applicability then is we're able to put down an AI system and identify where it's used, where it's relevant, where it's not relevant. Those lines in the sand from an ethical point of view, where shouldn't it be used, where can it be used, where has it been used previously? We have scenario building tools. Again, this is going back to the child approach. You've learned all this. How would you cope in this situation? Do the results make sense? And again, this is where you need to include the user in that, the expert in the loop, keeping the expert involved in the loop, and the multiple experts, different stakeholders. That's the standard that we use. I think I'll stop there, because what I actually want is some feedback from yourselves. What is the best way to test AI? Some questions for you. What would be a good approach? We've got some approaches. Are they the best? what would be the rationale for testing and the aims for testing an AI system. Right, so I'll leave it there and let's throw it out to question, put more discussion. So, some questions. Colin.
I'd like to suggest that testing of AI should be ethics, driven by ethics first.
Brilliant. Yeah, and we've got the ethics model in there, and that is a really good approach. And at least you're on a safe footing from an ethical stance. Yeah, that's good.
Can you not have AI to test AI?
Hmm?
Can you not have AI to test their own?
Excellent. AI. AI is used a lot. One area where AI is used in testing is to test software. Yeah, and that, we find some good examples of that. Then you go back to the other question: how do we test and how do we know that that software that we're using, that AI system, is tested? What level of confidence have we got? Yeah, but yes, and that has been suggested as one approach, especially if it's testing a system that has produced something outside our understanding. Yeah, how do we test something outside our understanding? Well, and AI has been suggesting that, but yeah.
So we've started working with our data science team, and one of the first things we've done is gone in to work side by side with the data scientists and say, right, you need to unit test your algorithm. Working with them to break their algorithms down into chunks, to start with, but then looking at what the algorithm is supposed to do and looking at the inputs and outputs and working out whether it meets the threshold of agreements and testing for the thresholds. If it's outside the thresholds, then you know there's something not working. But holistically, it's looking at what's the purpose of that algorithm, what's the system that it's going to be part of, what does that end-to-end system need to do, and that's where the testing principles come back in when we start looking at the overall testing piece.
Yeah, but that's a good testing mindset. What happens when the results come outside? Some possibly good results come outside of your initial set of requirements, if you like. It's oh, this is a new a new output. How do we know if that's passed or failed? Is it a good thing?
It's a discussion point, isn't it? At that point,
yeah,
isn't as clear cut as other systems. It's a discussion point.
One there and then back to you. Yeah.
I think it's a very good approach, right? I think all the models, at least lower level AIs, are dependent on the data that is going into the system, right? And garbage in equals to garbage out. So our first point of test approach would be looking into the data and what is being consumed by the model. And this is where ethics comes in as well, because parameters that model is going to be using going to be defined in the data set to begin with. So if you don't want the applicants to be discriminated based on their country of origin or their postcode, you exclude those parameters, right? Or make sure what weights are being assigned in the model to them. And in terms of requirements, right, yes, it's a challenging subject on defining what requirements have to be used, but nevertheless, you can still have acceptable ranges of outputs. And if your model does not perform in that percentage output of accuracy, you can iterate on the model until it's improved. And the business owner or product owner has to accept that the model will never be perfect, because otherwise it will be overfitted, right? So there will be always some inaccuracy part in it.
Yeah, I agree. There's always going to be all the things we've learned from software is that you're going to have embedded biases, embedded problems with it. It's not going to capture all the elements. And the biases, embedded biases, a lot of data that they use for AI testing is coming from the West, the Western mindset, Western examples, Western businesses. The people that are using it are around the globe. We've got embedded biases all over the place there.
No, I was going to touch on inclusiveness, which is for automatic speech recognition and stuff. What's the training data? Like, that's kind of where I was going.
Yeah, it's a big question. And what data would be appropriate? I'd throw the response back to that. Yeah. There's an open call for anybody that wants to contribute to a book. If you've got something to contribute on your discussion of the issues, I'd certainly be interested on the automated requirements. How would that fit into an AI model and mindset? lots of interesting things there.